morning. In this video, we are going to start talking about normal distribution. And so normal distribution is a curve that is symmetric. And in the middle, we have the mean, which we're calling mu. So right here in the middle, you can see mu. And let me see if I can zoom in because this seems tiny. Ooh, too much. Okay. The mean, median, and mode of a normal distribution are all equal. So we don't have outliers. It's very symmetric. There's little out here and it goes up to big in the middle. And so they're, like I said, they're symmetric about the mean. And so since they're symmetric, since there's no outliers, then the mean and the median and the mode are all the same. It should make sense about the mean and the median being the same because of the symmetry, but then that tall height in the middle, that peak in the middle is what also gives us the mode at that same location. And then this one right here, the total area under the normal curve is 1. So all of this from all the way to the left, all of this area, all of that is equal to 1. And the reason that is helpful is because it reminds us of something else. That is one that I've been talking about a lot, and that is the sum of all the probabilities in a probability distribution equal 1. And so there's gonna be a lot of similarities between the probabilities and the normal distribution. I'm gonna pause it real quick because I need to get a water. All right, so you probably didn't really notice that I was gone, but I did get water, so I should be coughing less. Okay, so what we have here is we have 3 chunks separating, or we have our normal distribution separated into 3 chunks. And so this first chunk right here, right in the middle, that is everything that is 1 standard deviation away from the mean. So it's 1 standard deviation or sigma away from the mean. And the way we go either direction is we would add a sigma and subtract a sigma. And so mu plus sigma gets us our bigger value, mu minus sigma gets us our smaller value. And that is 68% of the area of this. Okay, remember the whole thing adds up to 100, 1 whole. So the next up, we have 2 standard deviations away from the mean. So it's everything from the left blue line to the right blue line, including the black part in the middle. So all of this right here, that represents 95% of the area. And everything in there is within 2 standard deviations of the mean, or 2 sigma. So when we go to the left, we subtract 2 sigma. And when we go to the right, we add 2 sigma. So mu is in the middle. So we take our mu and then we add the number of sigmas to get to the right, to the larger value, and we subtract that many sigmas to get to the left value. And then finally, we have 3 standard deviations away. And these are, the little red dot is kind of tiny because it's so far out. It actually takes up 99.7% of the data. So that will be almost everything. You'll notice to the left and to the right of my 3 sigma, there is a little space. So this isn't everything. This is not 100%, but it is almost everything. We would say anything outside of 3 standard deviations would be considered unusual, and anything or rare, and anything inside 3 standard deviations is considered usual. So it's within 3 standard deviations. Oops, I was trying to stay color coded, but somehow I changed colors. Okay, so 3 standard deviations from the mean. Oh, I tried to like flip my pen upside down like it was a real pen and erase, because I used to have a pen like that, but this one does not like to do that. Okay, 3 standard deviations. I don't know why I needed that to be color coded, but as you can see, that's almost everything, 99.7%. Okay, so we're just going to be practicing this idea a lot. And so first up, we have, so we want to kind of try to see the picture and the question. but it says X is a random variable that is normally distributed. So that means we're talking about the picture above. And the mean is 15 and the standard deviation is 1.5. So I know that for this problem, I have the mean is 15 and I know that the standard deviation is 1.5. And notice we're using the population notation. So we have the Greek variables, the mu and the sigma. Okay, so the first one says 68% of the curve area under the curve lies between which two values? So looking back up at the top, we see that 68% lies between mu minus sigma and mu plus sigma. I really need to stop highlighting this. I'm running out of colors. Okay, so mu minus sigma will be the smaller value and mu plus sigma will be the larger value. We don't really need parentheses there. I don't know why I did that. It's not, doesn't have to be an interval. But it's let me just write it out. Between mu minus sigma and mu plus sigma. So it's going to be between 15 minus 1.5 and 15 plus 1.5. So 15 minus 1. I'll just write these off to the side because I'm running out of space. But we'll say that it is between 13.5 and 16.5. Putting both of those, calculating both of those, 15 minus 1.5 and then 15 plus 1.5. So it's between 13.5 and 15.5. All right, 99.7% of the area. Well, looking up ahead or up top, we have mu minus 3 sigma and mu plus 3 sigma for the 99.7. So this will be between mu minus 3 sigma and mu plus 3 sigma. This is a number line. This picture right here is a number line. So the smallest stuff is on the left and the large stuff is on the right. This is a number line. So when we write these out, we want the smaller number first. So mu minus 3 sigma, that's 15 minus 3 times 1.5. And then 15 plus 3 times 1.5. So 15 minus 4.5 will be 10.5. And then let's see, between 15 plus 4.5, so that's 19.5. Okay, so that's just the basics of the picture, the mu plus sigma, mu minus sigma, all that. We're gonna be doing a lot of that, so it'll keep coming back. Okay, standardizing a normal randomly distributed or normally distributed random variable. So when we normalize something, when we standardize it, we kind of put everything on the same scale. So you might have heard of like standardized testing, or where else would you standardize that? It's usually like some sort of big test. So like the test to get into, like the SATs are standardized. The tests that you would take in elementary school, not the teacher test, but like the big state tests, all of those are standardized. And what that means is it doesn't really matter how many problems are on the test. We just rank everybody. We say the mean is 0, and we say the standard deviation is 1. And then we kind of figure out where everybody falls on this list. That's how we standardize something. Doing this process will give us a z-score. So the notation is, this is how you'll see some of the problems written out. They'll say X is such that it's normalized with mu and sigma. And the reason I'm pointing this out is because like this previous problem up here, it could, instead of all these words, it could have said this 1.5. It could have just been written like that instead of this whole first paragraph, and it would mean the same thing. So just to practice what the notation means. So when you see it on the homework, you'll know which one's mu and which one's sigma. So that's all that's telling you. And then once we do that, we're going to find the z-score. The z-score is found by saying that z equals x minus mu over sigma. X is the data value that we're talking about. And we want to know how many standard deviations above or below the mean that variable is. That's what the z-score is telling us. So I told you earlier that anything more than 3 standard deviations away is considered abnormal. And so when you're taking the z-score test, you want to be, whatever test you're taking, if you're taking some standardized test in to get into college or to pass 6th grade, whatever these tests are for, even the AP tests, all those things. You want to be above the mean. So you want to have a positive z-score because you want to be above average. But you're probably, you're probably going to be within 3 standard deviations. There's going to be a very rare, like Albert Einstein over there, that would be more than 3 standard deviations above the mean. Or there would be somebody that was really just in the wrong class and should not have been taking the test and knows absolutely nothing about the topic that would score less than 3 standard deviations below the mean. Okay, so let's just practice this formula. So we have our formula for z-score. It's x minus mu all over sigma. And so this problem right here is telling us that we have, with this notation, right? Oopsies, highlighted the wrong thing. With this notation right here, it's telling us that mu is 3 and that sigma is 1.5. That's what this notation is telling us. And then it also just blatantly tells us that x equals 5. Find and interpret the z-score. So finding it is just calculating it, plugging it into the formula. Z equals x minus mu over sigma. Now, let me go back to that page because there's something I forgot to write on this formula. The z-score, I didn't write it here. For this z-score right here, we're going to always round to 2 decimal places. In fact, it probably won't even tell you half the time. It won't even tell you what to round to because that's just the definition of z. Z needs to be to 2 decimal places. We're going to be using a table in another video or in many other videos. And that table is the reason why we are rounding to 2 decimal places. And so it doesn't say it very often, but that's the rule. And the reason it doesn't say it is because it is the rule. It's just what it is. Okay, so I have this problem. I'm going to put it into my calculator and I'm going to round to 3 decimal places. To 2 decimal places. And so I have 1 divided by 1.5 and I'm getting a point with a bunch of 6s after. So this is going to equal 0.67 and it's positive. And so if I look at this number line that we have here, mean is in the middle. That's 3. X is 4. That is bigger than the mean. So I expect this answer to be positive because Z is telling us, is our X bigger or smaller than the mean? So to find, that's how we find it. And then to interpret it, we would say our data point, something. You could just say X equals 4. Our data value is 0.065, whatever, I just said that so wrong. 0.67. It is 0.67 standard deviations above the mean. Okay, so whenever you interpret, the sentences are going to be virtually the same. So this, let me highlight the important parts. This word right here, above, it's either going to be above or below. Above is when Z is positive, below is when Z is negative. So in this case, Z is positive, so it's above. This number is always going to be the absolute value of Z. So in other words, that number is always positive. It doesn't matter if the answer is positive or not, that number is positive. And then the above or below will take care of the sign. It's just like saying if something was 3 steps, we'll just say if it's 3 steps below, we wouldn't say it's negative 3 steps below. We would say it's 3 steps below. It's either 3 steps above or it's 3 steps below. The above or below tells us which direction and if it's positive or negative, whereas the 3 is just the actual number of steps. So that's the absolute value. Okay, we'll do that again a few more times. Because looky here, we have find and interpret the z-score for 3 different problems. So in this problem, I see with that notation, I'm given the mean and the standard deviation. So the mean is, for all of these problems, is 315, and the standard deviation is 5. Oh my gosh, it looks so dark today. I forgot to turn the light on. Okay, hopefully you can see me over here. Okay, so we have find and interpret the z-score when x equals 310. So I have my formula z equals, so 310 is x minus mu. Now notice 310 is smaller than average because average is 315. So this is going to be a negative answer because it's smaller. 310 minus 315 divided by 5. So I put that in the calculator and I get -1. So here, we don't have to say our data value. We could just say what our data value is each time. We could say 310 is 1 standard deviation below the mean. I'm just abbreviating standard deviation as SD right now because it's too long of a word to write. So notice the 1 is positive because the word below takes care of the negative. Okay, let's try this again. We have, oh my gosh. I'll probably happen one more time. All right, we have 310, same mean. So 310 is smaller than mu. So again, I expect this to be negative because it's going to be smaller. So we have z equals 300 minus 315 over 5. Now, the mu and the sigma stay the same. So this formula looks almost identical to part B. The only difference is I have 300 instead of 310. So I do 300 minus 315 divided by 5, and I get -3. So 300 is 3 standard deviations below the mean. As I'm writing this out, I just remembered sometimes, I can't remember what Newton Alta does. It might say to the left. Oh yeah, I looked at it. Look at it right here, to the left or to the right. So let's go back and change some of those words, because if it says below, again, this is a number line. So below the mean is to the left. I just wanted you to see the same vocabulary that you're going to see on the homework. Okay, so below means to the left of the mean. So in other words, I have some space here. I have a number line. And I know 315 is in the middle because the mean is in the middle. Part A said 310. So it's below the mean, meaning smaller, but it's also to the left on the number line. Part B was 300. So that's also to the left because that's also smaller or below the mean. Part C, 319, is bigger. So when we get to part C, we're going to say it's above the mean or to the right of the mean. All right, so for part C, we have everything the same except the x value is 319. Mu and sigma are the same. All right, so now I do 319 minus 315 divided by 5. This one, so it kind of gets people sometimes when I say round to 2 decimal places and then they get an answer that just automatically rounds to 1 decimal place. It doesn't matter. If you want to put the 0, that's fine. I don't care either way. You probably don't care right now either, but you might care a little more when we get to the actual table and you see what we're doing with this. So it doesn't matter to me what you do with the 0.8 or the 0.80. Okay, so 319 is 0.8 standard deviations. Now we're above the mean. I just can't even possibly begin to spell this correctly. We are above the mean. And another way to say that is to the right. So again, this part right here is positive in all three examples because it is the standard deviation. Always positive no matter what the answer is. And then this part, negative. This part telling us negative. This part is telling us positive. So that's where it tells you the sign of the answer. Okay, a couple more we have. And so this is just practicing the formula. And now in these problems, I notice it's saying what the z-score is. Okay, so, and it says, what is the mean? What is the standard deviation? So we're going to use the same formula, but now a little more algebra is going to be required. Whereas on all the previous problems, you could literally just dump it in your calculator and you'll get the answer. Okay, so in this problem, I have z equals 1, x equals 2, and then it says the standard deviation is 1/2. What is the mean? So I'm going to plug it into my formula. Z equals x minus mu over sigma. And now I have to solve for sigma. So if you are at all having like algebra issues in this section, let me know. I can give you an extra worksheet to practice these because it's very important that we're not like getting bad grades because of algebra, because that's in the past. So we want to get caught up on the algebra and then make sure you're getting the statistics. All right, so we're going to multiply both sides by 1/2 because this problem is dividing by 1/2. So I want to undo that. So I'm just going to use the decimal at this point because I want my answer as a decimal anyways. So I have 1/2 equals 2 minus mu. I'm going to subtract 2 from both sides. And I get negative 1/2 equals negative mu. And then finally multiply or divide both sides by -1 to make sure mu is positive. So the final answer is mu equals 1/2. Okay, again, hopefully the algebra isn't killing you. Please let me know if it is. These two types of problems, 4 and 5, are like as algebra as it gets. And then 6 has some algebra on it too, but 4 and 5 are the two different styles. Okay, so here we have z equals negative 1.5, x equals 21, mu equals 24, and we want to know what the standard deviation is. So we have negative 1/2 equals x minus mu, 21 minus 24, all over sigma. I need to undo the fraction first, so I'm going to multiply both sides by sigma, and I get negative 1.5 sigma equals, and then 21 minus 24, that's -3. Let me rewrite that where I have a little more room. Negative 1.5 sigma equals -3. So now I'm going to divide both sides by negative 1.5 because that is with my sigma. And we get sigma equals 2. All right, I'm showing every step. It's not necessary. You show as many steps as you need to show to get the algebra done. Okay, last one. Yeah, last one here. It says Jennifer's test score was 94. Test scores are normally distributed. It tells us right there what sigma and z are. What was the average test score? So when they're asking for the average, that means they're asking for mu. And if I already know what sigma and z is, and I'm trying to find mu, that means this number right here, the 94, has to be x. So I have z, which is 5, equals 94 minus mu, x minus mu, all over sigma. Nope, I know what sigma is. Sigma is 2. All right, so then I multiply. So this is like problem 4, because you either know what there's 3 unknowns here. I guess there could be 4 because there could be x, but I consider x and mu kind of the same because they're both on top. That's one problem, like number 4. Sigma could be unknown, like number 5, or it could be like these problems where z is unknown. And when z is unknown, it's just an arithmetic problem. You just throw it in your calculator. But when you don't know the other 3, you have to do some algebra. Okay, so multiply both sides by 2. We get 10 equals 94 minus mu. Again, if you can do this in your head, do it. That's fine. Negative 84 equals negative mu. The point is, it just needs to be a positive answer. So we need to finally multiply both sides by -1 in order to get mu equals 84. The average test score for this class was 80. All right, tons more to talk about on this topic. However, that's enough for today or right now. So email me if you have any questions, and I'll see you in the next video. Bye.